My name is Mr. Kiarie and I lecture Advanced Financial Management. Last time we were doing what we call international financial derivatives. We considered ways of hedging and we considered three ways of hedging. The first one was option contracts. The second one was forward contracts. And the third one was future contracts. Today, I want us to illustrate how option contracts work. Under option contracts, we said there are two types of option contracts. The first one, we call it call options. We say that this is a contract that gives a buyer an opportunity or gives the buyer a right but not an obligation to buy the security, the underlying assets at a given exchange rate in future. We also consider the second choice, which we call it the put options. This one gives the seller a right but not an obligation to sell assets in future at predetermined exchange rates. So I want us to use an illustration question in the past papers to find how these two options are illustrated. Usually these two options use an option of a model of financial management we call Black-Scholes model, called the Black-Scholes model. We are going to consider a past paper question of September 2015. Question number 3B. The question reads, assume that your company has invested in 100,000 shares of Usaidizi Limited, a manufacturer of light bulbs. You are concerned about the recent volatility in Usaidizi Limited share price due to unpredictable weather in Uganda. You wish to protect your company's investment from possible fall in Usaidizi Limited share price until winter in 3 months' time, but do not wish to sell the shares at present. No dividends are due to be paid by Usaidizi Limited during the next 3 months. Usaidizi Limited's current share price is 20, the call option exercise price is 22, time expiry is 3 months. Volatility of Usaidizi shares is 50%, which represents the risk, or rather the standard deviation. And you are supposed to assume that the option contracts are for the purchase or sale of 1,000 shares. So you are required to devise a delta hedger that is expected to protect the investments against changes in share price until the weather changes. Delta may be estimated using ND1. Therefore, you are supposed in this case to determine the value of D1. In this case, the formula of D1 is computed as S over E open brackets plus open brackets R plus 0.5 times the standard deviation squared, then all that you multiply by T. Then you divide all these by sigma, which is the risk, times the square root of T. In this case, S represents the current market, the current share price. E represents the exercise price of the options, Then R represents the expected rate of return, Then T represents the time period. Then the sign of sigma, that is the standard deviation. deviation, or rather the measure of risk. Therefore, using this question, we are going to get the value of S. S is the market, the share price, which is 20 over 22. This one is indicated as in brackets. Remember to do that. It is taken to be a negative, plus the rate of return. The rate of return is 0.1, plus 0.5 times the standard 0.5 times the standard deviation squared. The standard deviation in this case is 50%, which is 0.5 squared, 0.5 squared, then times t. Therefore, you are going to take the values, then you divide all these, by the standard deviation, which is the risk, times the root of t. That is the root of time. Therefore, in this case, since time is 3 months, you take 3 months over 12, it will give you a quarter, or rather 0.25. Therefore, you can replace this with 0.25 and this with 0.25. If you work it out, this one will give you a value of negative 0. We get the values, it will give you a negative 0.156. To the nearest whole number, this is almost negative 0. This is almost equivalent to 0.16. Then, in the second part of the question, before we get to the second part of the question, to get the value of D2, we say it is equal to D1 minus the standard deviation of times the root of time, Therefore, in this case, we know that our D1 is negative 0.156 minus open brackets. The standard deviation in this case was 0.5. Times the root of time. The root of time would be, in this case, time is 0.25 times 0.25. Therefore, if you work out this one, it will give you a value. If you work it out, it will give you a value of 0.41, which is a negative. Therefore, in the second part of the question, you are required to indicate or to comment on whether such a hedge is likely to be totally successful. In this case, you consider the value of D1. D1 was negative 0.156. Since this would lead to loss of value, it means that the hedge is likely to be highly successful. And that is how you go about financial derivatives using a model of Black-Scholes model. Thank you.